Okay, this video is going to go over Chapter 19, Objective 6. So I hope that you had a chance to take a look and go over those videos over the conduction system, because we're going to go a little bit more in depth in this. You do need to know what an EKG is, or an electrocardiogram. It could be EKG or ECG depending on how you're spelling cardio. Basically where you're from is what that's coming from. So it's used to check for signs of heart disease. It records the electrical activity or the signals of your heart. So if you've ever had one of those done, they put all these little stickers that are attached to cables all over you. You can see the little person in the picture there. They've got all these little stickies. And the process takes, my gosh, it takes longer to set it up and to put everything on you than it does to actually run the test. They push a button. We're talking like 5 to 10 seconds, and then they're taking the stickers off. So again, it really does not take long at all. It takes longer to set it up and to take it down than it does to actually record the electrical signal. The signals are then going to be shown as waves on a computer monitor or printer, and then that's going to go to the physician. So again, this is one of the same videos that was in the previous objective that I encourage you guys to take a look at. So again, you need to know contraction, depolarization, systole, all mean the same thing. Relaxation, repolarization, diastole, all mean the same thing. This just gives you a short reminder of what we previously talked about in the Objective 5. So when we're looking at the EKG wave, it produces a composite tracing of all the nerve impulses generated by those myocardial cells. Those are going to be your cardiac muscle cells that are going to be found in the myocardium, the middle layer of the heart. So, like we said previously, the sinoatrial node, also known as the SA node, is the pacemaker. The electrical signal for the heartbeat begins here, and it's located in the right atrium. Hopefully you remember the visual from the previous objective. The P wave, during this part of the EKG wave, the atria are contracting. Then the signal is going to go to the AV node, also known as the atrioventricular node. Now, this is also known as the gatekeeper. So what happens is, if you remember visually the muscle contraction graph compared to the nervous system graph, the depolarization, repolarization graph, and the time that ran along the x-axis. For an action potential, it takes milliseconds, okay? However, for the muscle to contract, that's going to take a little bit longer. We talked about that in Chapter 10. So if you've got your electrical signal going from the SA node to the AV node, that's going to happen instantaneously, very quickly. And that is going to tell the cardiac muscle cells in the atrium to contract. And remember, that contraction is going to take quite a bit longer in comparison. So if you don't slow the electrical signal down, the entire electrical system is going to go through the entire heart, and the atrium are still contracting. Okay, that's not going to do any good. So you're going to have like the atrium and the ventricles contracting on top of each other. Blood's not going to go anywhere. So the AV node, the gatekeeper, is going to pause that electrical signal to let the contraction catch up with it. Otherwise, your P wave is going to be on top of your QRS wave. So the signal comes down through the atrium. It's going to get to the AV node. AV node is going to pause the electrical signal. The atrium are going to complete the contraction, and then the electrical signal is going to go into the ventricles, where the ventricles can then contract, because now they'll be full of blood at that point. So the QRS segment, this is the contraction of the ventricles. The Q wave, this is when the electrical signal moves to the bundle of His and down the right and left bundle branches. The R part is the contraction of the left ventricle, and the S wave is the contraction of the right ventricle. So while the atrium actually both do contract at the same time, there's a little bit of a delay, and we're talking milliseconds of a delay, between the left and right ventricle contracting, just a hair difference. And you can see right here, because this right here, this low part is the Q, then way up top is R, and then way down here is S. So time-wise, we're not talking about a big difference at all when we're dealing with the electrical signal. And then the T wave, this piece right over here, That is the ventricles relaxing. And again, you can take a look at this if you want. Why would a doctor ask for an EKG to be conducted? Again, suspicion of a heart attack, a pulmonary embolism, third or fourth heart sounds, murmurs, structural disease, these kinds of things. This is why they might ask for one. I'm not going to ask you on the test. Again, this is something you're going to learn in the nursing program if that isn't in fact what you're doing. So again, just showing you, in case you were wondering where they place those electrodes, just kind of showing you how that all is. And if you actually watch when they're doing the EKG, there's little tags on all of those wires, so the tech knows where to put each of those wires, so it comes out the right way on the, there's a lot of wires. Some of them can use all of them, some could use fewer, so you don't have to use all the electrodes, but that's where they go. So I'll give you a second to take a look at set 6. Okay, so the name of the test is an EKG. I threw up some other words that we have not discussed really. So, well, you should know what an MRI is, but just make sure you know the name of the test. It could be EKG, could be ECG. No, an echocardiogram is not the same as an electrocardiogram. Two different tests. Number 2, which part of the conduction system is responsible for slowing the electrical signal down between the atria and the ventricles? That's going to be the AV node, the gatekeeper. Number 3, what part of the EKG are the ventricles relaxing? And that would be the T wave. And that concludes this objective.